Okay, good afternoon, everyone. If you have any questions about the homework, please get going. I see somebody raising their hand. Okay, go ahead. If you have questions, put it on chat or just speak up. Okay, how did the homework go? Did you guys do your practice problems? Okay, the way it will go that every time we start, I expect you to have done your practice problem and eventually your Moodle problem and ask me questions. And if you're struggling with them, and then I will go over them, make sure you understand them. So back to my question, any questions from the homework? The practice problem, that's what you have. Okay. All right. So we keep going. So we keep going talking about the graph. So last time what I did is I gave you a graph. Okay, number 3A. So you have to do that at the beginning. So there will be no interruption. So number 3, part A, which section, Leah? Is it the worksheet? What is it?
Sorry, the worksheet.
Okay.
1.3.
Very good. I'm gonna do all this problem. All right. So before I do this problem, let's talk about the following. Last time in class, what we did is, if you remember, I gave you the graph basically, and I asked you find. So we are trying to understand what a graph is, and what we've talked about that if I ask you to find f of -3 is the input, and the output is the vertical distance from -3 till we hit the graph. That's really what we did last time. Today we're gonna go in the following. Suppose, so how to sketch the graph of a function, and then we do number 3. So how to sketch the graph. So instead of giving you the graph, how to sketch it. Oh. Yeah. Okay. So how to sketch the graph. So suppose I give you a function, and the way I'm going to give it to you, instead of giving you the formula f of x equal x squared, I'm going to give you the function as a table. So let f of x be given by the table below. What do I mean by that? Be a function whose values are given. Whose values are given by the following table. By the table below. So what do I mean by that? I have a table, okay? X, f of x. So 0, 1, 2, 3, 4, 5. And I'm gonna pick -1, 0, 4, -2, 1, 2. Okay, that's really the table I have. So how do we read this table? It means that here I have all the input values, and this is the output that correspond to the input. So how do we read this table? It means that I have a rule. The domain means the input values are, so here the domain or the input values are 0, 1, 2, 3, 4, 5. Those are the input values. And this rule is doing the following. It's sending 0 to -1. That's what this rule is doing. It's sending 1 to 0. And so on and so forth. It's sending 2 to 4, and etc. So that's how this rule means. Now my question is, sketch the graph of f. Sketch the graph. What does it mean, sketch the graph? Sketch the graph means sketch all the points in the xy plane with coordinate input, the output that correspond to the input. It means 0, -1, 1, 0, 2, 4. So sketch the graph means sketch all point, sketch all the point with coordinate. The first coordinate is the input value. The second is the output that correspond to this input. Whatever the input is, the second is f of this input. So let's see what I mean by that. We take both axes. Okay, and on the horizontal, we put always the input value, crucial, the x values. And here we put the output values. So the input always on the horizontal, the output on the vertical. Now, what are my input values? 0, 1, 2, 3, 4, 5. So I'm going to put that 1, 2, 3, 4, 5. So according to what I gave you, these are the inputs, 0, 1, 2, 3, 4, 5. And then I have to sketch the point where? The following point. 0, the output that corresponds to it is -1. So if this is 0, -1 is right here. That's my first point. So the first coordinate input. The second is the output that corresponds to it. So this -1 is f of 0. Okay, now 1. What does my function send? It sends 1 to 0. So that's the point. That's how I'm sketching the graph. So all the points which have coordinate input, the output that corresponds to it. 2. My function is sending 2 to 4. So if this is 2, 1, 2, 3, 4, that's the point. Input, the output that corresponds to it is 4. And I do that for every point. 3. My function is sending 3 to -2. So 3 is going to be sent down here. My point right here. Okay, so that's the graph. Bunch of points, in this case, input and the output correspond to it. 4 is sent to 1. And finally, 5 is sent to 2. And that's the graph of my function using what I gave you. Okay, so sketching the graph, important, input on the horizontal, the output on the vertical, and you sketch all the points where the coordinates are, so that's 4 is the input, and the output that corresponds to 4, according to my picture, it's 1. That's really what we sketch, all right? Okay, so with this in mind, I'm gonna go do number 3 on the worksheet, that the ones that you guys are asking about. Questions before we go on? Good. So let's do number 3 on the worksheet. So this is the problem. We're gonna read it very carefully, and I want to ask you guys, what do you think about it? So that's the problem. In the Andes mountain in Peru, the number, so it's on your bright space in case you don't see that very clearly. So the number of species of bats changes with the elevation h above sea level. So you have bats there, and how many different kinds of bats depend on how high you are. Let f be the function that is assigned to each height h, measured in feet, the number of species of bats at the elevation h. So f is a function. So the number of bats changes with the height. And f is the function that is assigned to each height the number of species of bats. My question is, interpret the statement f of 250 equals 60 in terms of bat species, and give unit to 250 and to 60. All right, so this is my question. All right, so of course I want you to answer the question, not me. All right, who's ready? Who have a feeling of what's going on? Or first, let me ask you a question. My function f takes what? So this is my function. It's like a machine. You give it something, it has to assign to it something else. What do you give? And what is assigned to it? Before I even answer part A. Tyler, what do you think?
You'd have to give it the input value that goes along with it.
Yeah, what is the input in my problem?
The bat species.
Let's read the problem again. You have to read. You really have to read very carefully. What does f do? F is the function that assigns to each height h in feet the number of species of bat. I go back, ask the same question. What does it take for input? What is the thing they assign to? F assigned to what? What?
Is it the height measured in feet?
Right, because how does it read? It assigned to the height. So it takes the height and assign what to it? The number of bat species. Okay, so to understand the function, you have to understand it like this. You read the problem. What is it doing? It assigns to the height the number of bat species. As the height changes, the number of species are going to change as well. So what's this function taking for input? So also draw this little picture here for you to understand. So the input are what? The input are what you assign something to. So what's the input in this problem? Tyler, you're my victim.
Would it be 250?
No, I don't care about that yet.
Oh.
In this picture, F is taking what and assigning what to it?
F is taking the height and then assigning the species.
So the height is, what's the input? And the output, it means what's assigning to it is the number of bat species. So we're trying to understand what this function do, and then I can interpret this in a minute, number of bat species. Okay, so that's how we understand what it's doing. It's taking the height as input. You give it the height, the machine will give you the number of bat species. That's really what it is doing. And biologists will have to do those things to be able to study, population. I mean, they have to study it somehow. Now I go back to you. I'm still with you, Tyler. Now interpret this sentence. What does 250 represent in this picture?
The height.
The height. What does the 60 represent in this picture?
The number of species.
What does the whole sentence mean?
I'm not sure.
What does F do? To the height tells you the number of species of bat. So this sentence now means that if you enter a height of 250, what F will give you? The number of bat species at a height of 250. So F of 250, exactly. F of 250 equals 60 means at an elevation of 250 feet above sea level, there are 60 species of bat. That's how we read it verbatim. It means if the elevation is 250, that's what the function does. For the height of 250, it tells you how many bats there are at this height, species of bat. So if you are 250 above sea level, we have 60 species of bat. Okay, and the number changes the elevation. And this gives you a particular value. For 250, there is that much. If the elevation change, the number of species are going to change as well. So the output definitely is going to change with the input. Please ask questions about this before we move on.
Is this how you want us to write it? Like
Yes.
if you, for the quiz, so exactly in that sentence?
I mean, you have to convey the meaning, okay? I mean, if you write it slightly different, it tells me, okay, there are 60 species of bat at an elevation of 250. That's also correct.
Okay.
Is you
So
have to,
like any of these, the way that she wrote it would be fine if I were to put that on a quiz or a test.
if you word it a little bit differently, but correctly.
Yeah.
Yes, absolutely. Absolutely. It's English. So, okay. So the main thing here, 250, the unit is feet. 60, the unit is species of bats. Okay. Any other questions? Very good. Now, as I was saying a minute ago, is that the number of species changes with the elevation. Okay, here I gave you one value in part changes. So now I'm telling you some values of the function f are given in the table below. Sketch the graph of f using this data. Label your axis clearly. Okay. So what am I talking about? We're gonna see how the number of bat species changes with height. So we're gonna show this by graphing the function. All right. So graphic means we have the two lines. What shall I put on the horizontal axis?
Input.
Input, which is what?
0, 50, 100.
Yeah, but what is it? What does the input represent?
The height, feet.
The height, crucial. So this is height in feet. That's the input. The output. So what should I represent on the vertical axis?
Species.
Okay, number of species of bat. Okay. Now, what are the input values I'm interested in? 0, 50, 100. So it's changed. The input always changes. As the input changes, your output is changing. So the values are 0. Now, since it's 50, 100, 200 to 50, a good way to scale this with 50, 60, 100, sorry. Oh, no, my apology, my mind went blank. 50, 100, and 200 should be here. So that should be 150 and 250. Somehow I forgot to give you 150. Okay. Now, scaling of the output. How do you want me to scale the output? Look at the value and tell me, okay, if I'm going to put those, what do you want me to put?
By tens.
So you want me to put by 5, by 10, by 20? How do you want me to put them?
By 10.
By 10, because we look at the output. By 1 is tedious because I need to go all the way to 100. So we're going to put them by 10. So it's a 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And my apology because it's a bit messy here. So 70, 80, 90, and 100. Now we sketch the graph very slowly. The height is 0. I have 100 species. That's my dot. If the height is 50, I have 80 species. So that's the height. That's my point. If the height is 100, I have 70 species. That's my point. You have to do it as active. That's what it means to grow. Now, if the height is 150, I didn't give you data. It was my mistake. If the height is 200, I have 65. So I have to go all the way to 65. So right here, that's 265. And then if it's 250, it's 60. So I go up here, right there. If the height is 250, the output is 60. And then that's really, given the data, that's the graph. Okay.
Do we actually have to graph it, or we could just leave it like that?
You have to leave it like this because we don't know the biology of it. It seems from the number I gave you that the higher we go, the less number of species of bat we have, right? That's really the tendency. But since I gave you only this data, you can just stick to that because we don't know the biology very well. If we knew the biology, we could say, you know, it seems to be decreasing. But for now, just keep the data the way it is. Okay?
Okay.
Is that clear? Any questions? All right. Now, along the same line, we want to do the following problem. Still sketching. So on your bright space, you have worksheet for section 1.3, 1.6, which is exactly this one. So if you don't see that, you guys can look up bright space and it's very clear. I read it and I will let you think about it for a minute and then we get together and see what you guys come up. First, let me read it. On the grid below, sketch the graph of a function that has the following properties. The smallest number in the domain of f is -3. What does it mean? It means that up to -3, I want output. And there is no output before -3. The largest number in the domain is 4. Means there is no output after 4. The output stops at 4. So it means the picture that you're going to draw me is between -3 and 4. Every value between -3 and 4 is in the domain. It means for any input here, I want an output. And it's up to you to graph this. And then I wanted to satisfy the following condition. I want my function to take 1 to 0. I want it to take -3 to 4. I want the value at -2 to be exactly the output at 1. And I want the output at 1 to be less than the output, the output at 3 less than the output at 1. I'll give you 1 minute, all of you, and sketch it in front of you. And then I will ask one of you to see what did you guys come up with. Okay, get going. Take a scratch piece of paper and just graph it yourself and see what can you do. Please, those without a video on, please try to put your video on. Are we ready? Or not yet? How's comfortable? I'm going to pick one of you and we can discuss it. Cindy, are you with us?
Yes.
Okay, what did you come up with? Any ideas?
Are we just graphing them?
Yeah, how are you going to graph it?
The first one, you just put 1 on the horizontal axis, and then you go to 0.
Which is, keep me where I am.
Yeah.
Right, okay. So you took the first condition. Very good. Then keep going, you're fine.
I put -3
Yeah,
on the horizontal and I went up to 4.
very good. This is satisfied. Keep going.
And then -2,
On the horizontal, right?
yes, and then 1 on the
Yeah,
vertical
so
axis.
-2, f of -2 is equal to what?
F of 1.
Which is? What is f of 1?
0.
Yeah, don't be afraid. You're doing fine. You're doing very fine. Right there. Keep going.
And then it would be, could you put -1?
Why not? The only thing I ask you, less than f of 1. The value at 1 is 0, so it means that value at 3, I don't really care. You can put it anything you want.
Okay.
Okay, so this is satisfied. So far, so good. Now, what else do we need? We're not done. Why we're not done? Anybody can tell me why we're not done?
We don't have the largest number in the domain of 4.
Exactly. So what shall I do? And every value has to be in the domain. Okay, so now she satisfied all those conditions, absolutely correct. But now I'm going to start connecting dots. So every value is in the domain. Now, how do you connect them? Actually, you have a lot of freedom. So I can connect this to this. And I want everything up to 4. Now, for example, I can go up like that if you want. And then I can go up to 2. And then I can go up to 4. That's one possibility. Okay, so once I satisfy all those requirements, if I want every value in the domain, it means I want an output for everyone. So that's one possibility of doing that. So satisfy and then connect the dots. Okay. Any questions about this exercise? Today we're gonna, yes, I'm listening.
I was just a little bit confused with the f of 1 equaling to 0.
Yeah.
If you could just go over that just real quick.
Sure.
And then I also had a question too with the last one with it being less than 3 or less than 1.
F of 1 equal to 0. It means that the function does what? It sends 1, that's for input, to 0. That's the output. Okay? So it means graphically, if the input is 1, what's the output? The input is 1, the output is 0. So when I sketch the graph, I need this point on the graph. So 1 is always, that's an input, is on the horizontal, but what is 0? It's this point right on the x-axis. So this point is 1, the other one is f of 1. But f of 1, I'm telling you, it's equal to 0. So it's the point right here. Because every point on the horizontal axis, its y-coordinate is 0. So I want the point whose y-coordinate is 0, which is this point right there on the horizontal axis.
Oh, no, I was talking about the f of -2 equals f of 1.
I'm sorry.
0. I'm sorry.
Okay, I gave you that. But f of 1, I told you it's 0. It means f of -2 have to be 0.
Oh, okay. So if it was already given, then that's
right. It's already given
with what was given before.
Yeah.
Okay.
Okay. When I talk for too long, tell me that, you know. Okay. Anything else? Now, I wanted at 3 to be less than f of 1, but I told you at f of 1 it's 0. So you want to be negative. So it has to be down here. You can pick any value you want. Like you can pick -2. I don't really care. But the only thing I want to be less than 0, it means I want it to be negative. Okay? So you have flexibility with f of 3. As long as it's negative number, you're all right. So if you put f of 3 here, that's wrong. Because then f of 3 will be bigger than f of 1, which is 0.
Since we had to make our own domain, like a part for like for the fourth, do we just pick any number that we want?
For 4?
Yeah. Do we
Oh,
just pick any
yeah.
number?
Yeah, I mean, I can graph it like this. I can graph it like that. I will add a color. I can do this.
Oh, okay. So it could be any number as long as
Any
it's
number. Yeah, because I did not put any restriction for f of 4.
Okay.
Okay? Then you can play with it. But f of 3, you have to be careful. It has to be less than 0. All right? Any other questions?
So could f of 3, could it also be like -2 if like?
Well, of course it can. No problem.
Okay, thank you.
Yes, it can. The only thing I want it to be negative. All right? Any other questions? Yeah, you have flexibility. Okay. Now we're going to move to section 1.6. Now 1.6 is basically the same ideas, but we are adding a little bit of fraction to it. So before I do 1.6, I'm going to review very quickly fraction. I hope all of you know it. If you don't, you have to review it because we have to work with fraction. So a quick review, very quick review of fraction. Very quick. Before I take up a problem from section 1.6. Quick review of fraction. All right. First, adding fraction. We have two cases. Same denominator. And different denominator. Okay, first same denominator. The idea is, if you have 5/3, it means you have 5 pieces, each one of them links 1/3. And you add 7/3. So basically here, 5/3, it means you have 1/3 plus 1/3 plus 1/3 plus 1/3, 5 of them. And you add 7/3. So the same denominator, you just add the numerator. 12/3. Okay, I know it's 4, but we add numerator. So if you have A over C in general plus B over C, same denominator, you add the numerator. Very basic. Now, different denominator. So when the denominator are different, of course, we cannot do that. So different denominator. So if I have 5/3, but I add to it 7/4, now I cannot combine because those are 5 pieces. Each one of them is a third. And that's 7, each one of them is a fourth. There is no way to combine the numerator. This is where we have to find common denominator. Okay, and what's the common denominator here quickly?
12.
12. Okay, and then, so different denominator, we have to find a common denominator. Crucial. We cannot add them otherwise. Okay, the common denominator, it means it's a number that's a multiple of 3 and multiple of 4. 12 is the multiple of both of them. And then we proceed. Okay, 3 to get to 12, I multiply by 4, multiply by 4. 4 multiply by 3, multiply by 3. Now we're not changing anything. Now it's going to give me 20 over 12 plus 21 over 12. Now I have the common denominator. I have the same thing. Now I can combine and we're done. Over 12. Okay? So this is for adding. Now multiplying fraction. I'm going to also take like two cases. Suppose I take 4 times 2/3. So 4 multiplied by 2/3. So this is what it means. That's 2/3 times 2/3. Sorry, my apology. Plus 2/3 plus 2/3 plus 2/3. That's what it means to multiply by 4. Which is very easily 1, 2, 3, 4. So this is the same denominator. So it's, and I add this 2 plus 2 plus 2 plus 2. That's four of them, which is 8/3. So if I have a number like 4, 5, 6, and I multiply it by a fraction, so this is equal to, so A times C over B. So that's the first case. Now, if I have two fractions, like 4/7 times 2/3. So it's not like 4 times 2/3. How do we multiply fraction? The way we multiply fraction is we multiply the numerator over the denominator, which is going to give me 8/21. So how we multiply fraction? We multiply the numerator over denominator. That's multiplication. Times t. Okay? So whenever you're working with fraction, you have to follow those rules verbatim. Don't come up with your own rules. Now, how to divide them? I know, of course, you know this stuff, but for me, I have to remind you. Division of fraction. How does it work? So if I have 4/7 divided by 2/3. So how do we divide fraction? The rule goes like this. If you have A/B divided by D/C, this is equal to A/B times what?
D/C.
D/C. Now that's a multiplication. Well, we know how to multiply. It's product of numerator over product of the denominator. So if I have 4/3 divided by 2/3, this is 4/7 times what? 3/2. So that's 4 times 3/7 times 2, which is 12/14. Which is, if you want, the same thing as if I did, okay, 12/14. Okay, so that's how we divide fraction. As I said, that's a review. That's not, no more than that. Finally, powers of fractions. What do I mean by that? So suppose I have 2/3. I take it to the power 2. What does this mean? What does it mean to the power 2? It means 2/3 multiplied by 2/3. All right? We're multiplying them. Now, how do we multiply this? It means it's 2 times 2 over 3 times 3. But 2 times 2 it's like taking 2, raising it to the power 2. We divide it by 3 to the power 3. Okay, it means 4/9. Let's take another one. Suppose I take 2/3, raise it to the power 3. What should we get? And then what's the rule? Again, it's 2/3. That's what means the power 3. I multiply it by itself, and I multiply it by itself. So this gives me how much? 2 times 2 times 2. Product multiplication of fraction. Over 3 times 3 times 3. This gives me how much? 2 times 2 times 2 is 2 to the 3, power 3, over 3 to the power 3, which is 8/27. So in general, what is the rule? If you have A/B and you raise it to a power, so n represent an integer, it's like taking A to this power divided by B to this power. All right? So what do I mean by that? So for example, I tell you, evaluate 2/3 to the power 4. So my power here is 4. So this is the same thing as 2 to the power 4 divided by 3 to the power 4. You can kind of split. And the reason is the same thing as here. It's 2/3 times 2/3 times 2/3 times 2/3, which will give you that. And now we plug in into our calculator, we get 16 over 81. Okay, so that's a very quick review of fractions. For those who forgot, please keep them in mind, and anytime you work with fraction, make sure you use the rules correctly. Can I move on? All right, now we're going to apply those to functions. So again, we're working with function. That's really our goal in this course, is work with function. So now I'm going to take the following worksheet together, and we're going to work with it. All right. Let f of x be equal x squared plus 3x minus 4. It means f is a function. You give it an input, whatever you give it, that's what f does. It associates to it x squared, it's square what you give it, plus 3 times what you give it, minus 4. As x vary, as your input changes, your output is going to definitely change with what you give it. That's what the function does. And that's the graph of it. What does it mean, the graph? It means every point here is a particular point. Whatever the input is, so let us assume this is 5, for example. If this is 5, the output is f of 5. That's really what the graph means. And the way your calculator sketch the graph is actually by doing the following. That's how it does it. It takes a bunch of input value. So it takes -1, -0.5, 0, 0.5. Take a lot of input, and they find the output. And they draw a point, like we did previously, and then they connect them. That's physically what the calculator does, exactly what we did in class, but they take a lot of input value and connect them. All right, now we're going to start. Question number 1 is, find the missing coordinate of the point A and B. This is my point A. It's a point on the graph. The first coordinate is 0. My question is, find this. Okay, I gave you 1 second. No, I gave you 30 seconds to give me the answer, and then I will pick one of you. Okay, Charles, what do you think? Are you with me?
Yes, I am.
What do you think this coordinate is going to be? How shall we think about it?
I think it's going to be -2.
Why?
Because if you meet the points together at the slope.
What slope?
Well, from, I can't point to, but down from 0 to -2, A to B.
I don't have any scale here, so you have no idea what's in here. I don't have scale for a reason. Let us think one more. This picture here, this little curve, this parabola, is the graph of this function. What does this mean? It means if you take any point here, let us remember the graph. If this is the first coordinate is an input, the second should be the output at this input. That's what it means, the graph. It means whatever you take a point, whatever the first coordinate is, the second should be the output for this coordinate. That's what it means, the graph. That's what does this picture represent. So what am I talking about? If this is 0, the second should be f of 0. So that's how we find the second coordinate. That's what the graph means. It means every point here is specific. Whatever x is, this is going to be the f of x. So if this is 0, this is going to be f of 0. So to find the coordinate of the point A, I need f of 0. So for A, the input, which is the x coordinate, is 0. Now, I need f of 0. What's f of 0? What does f do? 0 squared plus 3 times 0 minus 4, it's minus 4. It means that the point A has for coordinate 0, minus 4. Are you better with me now? That's what the graph means. It means every point here is very specific. Whatever the x coordinate is, the y is totally constrained by the x. It's the output as x. Okay, I stay with you, Charles. I want you to give me B, see if you followed me.
It'll be f of -2.
Right, it's going to be f of -2. So what's the input here for B?
Oh.
-2.
Very good. What's f of -2?
Slowly.
We'll do it slowly.
Equals 3 times -2 minus.
No, you're not reading it well. How that?
Oh, okay. Sorry.
Yes.
-2 squared plus 3 times -2 minus 4.
Yeah, this is equal to what?
4.
I expect you to work with me, all of you.
4.
It's 4.
Yeah.
Minus 6. Minus 4, right? Equal minus 6. So the point B is -2, -6. That's the point B. That's what the graph is. That's what the points on this picture means. So now if I give you the point C and I give you 5 and ask what's the second coordinate, is it an easy or a hard question now? I take this point C. I tell you this is 5. Is this, find the interrogation mark. Is this an easy or a hard question by now?
Easy.
What's this?
F of 5.
F of 5. That's what it means, point on the graph. That's what characterizes this point. If I take this point here, like this is 5, I take a point right there. If this is 5, I have no clue what this is. Could be anything. The point, if the point isn't the parabola, it means if this is 5, this is the output at 5. This is what characterizes those points. That's what this picture represents. All right. Part B. Find f of 2 over 5. What am I asking is, what does 2 over 5 represent here? An input value or an output value? Let me pick another one, another student. Amber. Are you with me?
Yes.
Okay. How am I supposed to find f of 2 over 5?
Would you still plug it into the equation like we did the other one?
Exactly. So I'll give all of you 1 minute to work on it and then do it on a scratch piece of paper. Then I will pick it up here. So I'll explain it well. So try to do the algebra. And I want the question as 1 fraction. I don't want decimal for now.
Can I see the original rule real quick?
Absolutely.
Thank you.
right? Who would like to take the lead?
I can.
Go ahead, go for it. What do you want me to write? I wrote the first two. What do you want me to write here?
So right there, so it'd be 3 times 2/5. And then -4, obviously.
Yeah.
And I believe that comes out to -2 and 3/5.
I'm very slow. I want you to guide me through your answer.
Okay, sure. So 2/5 squared is just 2/5 times 2/5, which comes
Okay.
out to 2/10 or 1/5.
No. No, let's do it. Correct? Am I right? All of you. Plus.
Yeah.
Yes, please. Very good. Equal to what?
Okay, so 2/5 times 2/5 equals 2/10.
How? How do we multiply fraction? Let's go back. That's why I did this. That's why I did that. How do we multiply fraction?
4/5.
Right, no. We multiply the numerators. Over
25.
Well, 4 over 25.
Hmm.
2 times 2, those are the numerator, over 5 times 5. Are you with me? It's not tens, no. If the product of the numerator over the product of the denominator. That's why I reviewed fraction with you. Plus 3 times 2/5 is how much? Quickly.
6/5.
6/5.
6/5 minus 4. Okay. Now I want you to give it as one fraction. So I really want you to find a common denominator just because you want to practice this. That's really why I want this. What do you think is a proper common denominator? It means what is this number that's a multiple of 25 and 5 at the same time?
25.
25. So let's finalize this. Now common denominator is 25. 5.
30.
5 times 5, so this has to be multiplied by 5, so this has to be multiplied by 5. Now this is 4 over 1, so if I want 25 here, I have to multiply by 25. Now I am safe. Sorry, plus. Minus 100 over 25. Now I have same denominator of 25. The rest is nothing. I add the numerators.
Oh.
Okay. Now 30 minus 100, that's minus 70. Add 4 would leave me with minus 66 over 25. Okay, and that's exactly what minus 66 over 25. Yeah. And that's really what I hope. When I say I want one fraction, actually, I really want you to do this stuff and get to one fraction. Okay? All right. So that's it for today. For Tuesday, I'm going to assign problems along those lines and as a practice problems, and you have to do them. Now, 2 things. A lot of you did not try to log into Moodle. By Thursday, I'm expecting all of you to have logged on to Moodle so I can explain to you how to work it out. But I want all of you to log into Moodle. And if you have difficulties, we have to, look into them so you have access to it. The practice problem, as I told you, those are for you to practice and to learn the materials. Those were not to be handed in. The Moodle are the one for grade. So please have them registered by Thursday. And now finally the quiz. How are we going to take the quiz? I want you all, I'm going to share the screen with you. I want you all to go to Brightspace. Okay, all of you go to Brightspace. Okay, and right, are you all on Brightspace? Go to the content page, all of you. On the content page, go to quizzes and exams. Click on it. Are you following my instruction?
Yep.
Now click on quiz. Quiz 1. Now the quiz is in front of you. You take it. If you can print it, it's fine. You cannot, it's fine also. You take the quiz on a nice sheet of paper. You write your answers very clearly. Then you either take a picture, whatever you want to do it, and you upload it into Brightspace for me. Please try to have it into a PDF document because that's the easiest, that's the one that Brightspace work with. The only one I have trouble with is the iPhone because it gives me a fold file that I cannot really read on Brightspace, something like HEIC. Try to avoid that. Otherwise, take a picture and upload it as a PDF if possible. And if you have any questions, put them on chat and I will answer them, but privately. Put them privately on chat. Good luck.